So friends, we are back once again with tutorial 10. The exercise which we carried out in tutorial 9 for setting of phase over current relays in case of a simple interconnected network. The same exercise we are repeating for ground relays. So in an interconnected system, how the ground relays would be set, that exercise we would be doing. I would request all my friends and viewers to be very attentive. Probably they will have to hear the video many times, more than once, to understand, because these things I have never taught when I was in BBM Engineering College for 26 long years. I joined in 1986 and retired in 2012. In the process, I was myself improving, and person must be improving day by day. I was also not teaching, or I am yet not teaching in Nirma Institute of Technology, where I go, right? And wherever I go, there also I don't teach these things because the time constraints, because I am given limited number of lectures, and in those limited number of lectures it is difficult to teach everything. Here when I'm going for videos, I have enough of time, so I can teach many things. That in PDEU, Pandit Dindayal Energy University also, I have not been teaching so many things in depth in power system protection. So these are the new things which are coming to you. So please be attentive and hear. So we go, this is the system. This is the system, same system, nothing new. As I told you, I am avoiding generator relays now, because then I would be complicating yet more. So I am not going into that. So this is 3 generators on one side, two generators on the other side. R1, R2, R3, R4 wired for 3 overcurrent and 1 earth fault scheme. We have talked about all those 3 overcurrent relays, that is phase relays. Now we are going to talk about the ground relays, R1, R2, R3, R4. Fault F1 and F2, because I need not take other faults. That means near R2 I need not take, because the system is, both the transmission lines are identical. Therefore, these 2 faults will give me the complete solution. Loads are given, as you can see, right? So everything are given. We have talked that 10% of power is being utilized in rather running the auxiliaries. So we will deduct that power, and accordingly we go to the next slide. So in this interconnected power system, the data is like this: relays R1 to R4 are directional, normal inverse, overcurrent and earth fault relays wired for 3 overcurrent and 1 earth fault scheme. Overcurrent relays we have talked about, 50 to 200% of 1 ampere in 7 equal steps. Right now we are considering only 7 steps. In the forthcoming tutorials we will take more steps when we come to numerical relays. Right now, let us limit ourselves to 7 steps. That is the 50%, 75%, 100%, 125, 175, etc. That we are not talking right now. We are talking about ground relays, that is 10 to 40%, 10, 15, 20, 25, 30, 35, and 40. The loads at both ends are shown. Fault currents for faults at buses F1 and F2 are given here in this table. The triple line faults we have talked about, we'll talk about line to ground, that is on CT1 when fault occurs at F1. I repeat, friends, fault occurs at F1. Then current flowing through CT1 is 7933 ampere and through other three CTs, same current 1633. When fault occurs at F2, friends, fault occurs at F2, the currents in R4 will be maximum, that is 6059, that is 6059 and 2088 amperes in all other CTs, that is CT1, CT2, CT3, CT4. With these fault currents, we'll have to find out the TMS, right? And with the load currents, we cannot find flux setting because that was only for the uh, the relays of phase relays. The load current does not affect the ground relays. Therefore, ground relays, the flux setting is set in a different way. So we start love all, right? Up to this, it was all details of the example. Now the solution. Therefore, I am telling love all. When the badminton or table tennis or any play is starts, the referee says love all means on both sides 0-0, then 1-0, 2-0, 1-3, 2-3, that will start. So love all. Flux setting of ground relays. We assume that R1 to R4 are all 10% right now, immediately, right? Because they are not dependent on load current and minimum available is 10%, right? 10 to 40% setting range. So minimum available is 10%. So we take all R1 to R4, 10%. Time settings of ground relays, TMS of R1, we assume 0.1 because we have to start with something. I can assume 0.05 also. Fault current is 7933 as we have already discussed. Let us check up once again. 7933 for CT1. So for that 7933 fault current 7933 secondary equivalent because I've got the CT 1500 bar 1. So it comes out to 5.28 amperes. Therefore, current through the ground relay, I have to deduct 0.09, I think, right? Am I right? 0.09, what is the excitation current given? Let me check up once again. What is the excitation current that is given? The excitation currents are not given here. I think it is forgotten. But if I just calculate what is the excitation current, that I can find out that secondary equivalent is 528 and current through ground relay is 5.13. That is 5 and 1. That is 0.15. That is obviously 0.05 is the uh, excitation current per CT. That is 0.15 I have to deduct. If you deduct 0.15 from 5.28, it comes to 0.15. So at 8 minus 5, 3 and 2 minus 1, 3, 5.13 ampere will pass through relay R1. So relay R1 TMS is 0.1, 10%, right? 10% of 1 ampere, that is 0.1. Therefore, my flux setting multiplier comes out to be 51.3. Now the time of operation of R1, I cannot take 51.3 because highest I can take 20. We have many times talked, it is IDMT relay. Therefore, 3 upon log 20 into 0.1 that I have assumed. So 0.23 second. Therefore, top of R4, I'll repeat, R1, R4. R4 backs up R4, R1. Therefore, time of operation of R4 has to be 0.25 second further. So friends, yes, I am going for the same thing. R4, I am taking 0.25 second further. 0.25 means 8 and 0.48 second. Time of operation of R4 top, I write in short. I have been telling that I will be using some abbreviations because every time now and then to type time of operation takes time. So top means time of operation of R4 is 0.48 second. PSM of R4 is what? 1633, because 1633 is the current. Try to understand. Fault current is F1. It has not changed. Fault current is F1. But through CT1, 7933 was passing, but through R4, CT4 1633 is passing. So I have to take 1633. 1633 divided by 1000, because R4, once again, R4 is the 1000 bar 1 CT. R4 is 1000 bar 1 CT. So if I go back, R4 is 1000 bar 1633 divided by 1000 minus 0.15 excitation current divided upon 0.1, that is plug setting. My plug setting of R4 is 14.83. So I have to take 14.83. It is less than 20. So TMS of R4 is 0.48 into log 10 14.83 divided by 3. So TMS of R4 is calculated to be 0.1873, and in next 0.05 step I have to select 0.2. So what is my selection now? R1 is 0.1 and R4 is 0.2. That is true. Done. But now R1 should back up R4. R4 has backed up R1, but R1 should back up R4 for same settings. I cannot change the setting, my dear friends. Therefore, I will go for that. R1 should back up R4. So this PSM of R4 for 6059. Let me check up. R4 6059. See, last column 6059. R4 is 60. Others are 2088. So 6059. That is for fault at F2, and PSM is 59.09 because 6059 ampere is the fault current divided by what I have to do, the PSM I have to find out. So what is PSM? The PSM is 6059 divided by what? 6059 divided by 1000, because that is the 6.059 is the secondary current. 6.059 minus 0.15. That is what I have to do. And then that current will pass through R4, and that divided by what is the plug setting of R4, which I have calculated. Plug setting of R4 I have calculated to be plug setting of R4 is 10% only, same. So it comes out to be 59.09. I'll calculate, my friends. I'll calculate for you so that we are not in doubt, right? So let me calculate. 6059 is the current. So 6059 is my current. My CT ratio for R4 is 1000. So divided by 1000. So that takes me to 6.059. So that is the current through secondary of CT4, right? Minus 0.15 I have to do. So that takes me to 5.909, and that divided by 0.1 if I do, that is 59.09. Friends, I have used my calculator to calculate it once again. I had calculated howsoever, but to assure you that I am not doing any hustle puzzle. I am not making any, just to prove my example, I am not doing any wrong calculation. So 59.09 ampere, sorry, 59.09 is the PSM of R4. Top of R4, 59.09 I cannot take. So 3 upon log 20 into 0.1, so 0.4611. PSM of R1, my fault current is PSM of R1, my fault current. Once again, we will calculate 2088. So for 2088, what is 2088? For 2088, but R1 is 1500 bar 1. So 2088 divided by 1500. So that gives me 1.392 as a current passing through secondary of CT1. Minus I have to do 0.15. So that takes me to 1.242, and that divided by 0.1. 1.2 divided by that gives me 12.42. So 3 upon log 12.42, that if I do, right, then that gives me top of R1 and TMS of R1 I have already selected, friends, that I cannot change. TMS of R1 I have selected as 0.2, sorry, but TMS of R1 is 0.1, I cannot change. So that I, I just cannot change. So PSM of R1 for fault at F2 is 0.274. So 0.274 is top of R1 and top of R4 is 0.4611. What is my requirement? My requirement is R1 should back up R4. So time of operation of R1 should be more than R4. Here it is reverse. So R1 is not giving backup to R4. So I will have to go for second iteration, which I did not need. You were lucky that we did not need in phase relays. I will have to go for second iteration. That means I started with R1 as 0.1. Probably I have to start with 0.15 or 0.2, right? Then I have to do the same calculation. Same business I have to do. If it does not come out, I have to go for third iteration. I have to go for fourth iteration. My friends, I'm not going in. I have done that exercise myself. I have done many iterations, and then one final iteration that I found out that I am concluding here, that the final iteration is this, that if TMS of R1 is adjusted at 0.85, plug setting all 10%, remember, plug setting all 10%. TMS of R1, if it is adjusted at 0.85, and TMS of R4 at 0.9. Then time of operation of R1 for fault at F1 is 1.9599. You have to calculate. Similar method, right? And top of R4 for same fault location is 2.3 second. Because I have calculated, I have taken 0.9 and 2.3 minus 1.9599. It is 0.34. Shall we check up? 2.3. 2.33 means 3 minus 3, 4 and 1, 0. So 0.34 seconds ऐसा कुछ हो रहा है. That means I am coming out to discrimination margin of 0.34 second, which is more than 0.25. That means R4 backs up R1. R4 backs up R1. Now at F2, for another fault, top of R4 is 2.075 and top of R1 for same fault location is 2.33. 2.33 minus 2.075 is 0.255, which is more than 0.25. So after many iterations, which I have done, I am not writing here because my presentation would be too long and my time would not be 30 minutes, which I want to limit it. You can do for yourself. You can do this exercise. If you will do, then only you will understand, my dear friends. And then the module is there. Module 3 is there. There the exercise example is also given, right? So you can try all those things. But for that you will have to pay, because module 3 is not free of cost. This video is free of cost, right? So I have achieved. What I have achieved? R1, R2, R3, R4 plug settings are 10% and time multiplier setting of R1 0.85 and time multiplier setting of R4 0.9, all for ground relay. My result is achieved. My result is achieved. But friends, you will be astonished. You will be enjoying. I don't know whether I use the word romance in my when I teach the students. I use the word romance. When a boyfriend and a girlfriend meet, they feel romance. So when I teach power system protection to my student friends, I am feeling romantic. And if you feel romantic, then you will know the subject very well. It will be part of your lifestyle, right? For breathing, you are not to take any trouble. No, you breathe. Do you take any trouble in breathing? When you start walking, do you take any trouble? No. For doing all daily activities. So for solving the examples of power system protection, we should not be in any trouble. That is part of lifestyle, right? So that is the thing. That is what should happen. There was there is a saying that Einstein was giving many lectures for his theory of relativity. So his PA, personal assistant, told that you are giving a lecture of 1.5 hours, 2 hours to many countries, and you have given some 100 lectures to explain what is theory of relativity. Why are you not explaining me? He was a commerce man or arts man. He would not understand science. So Einstein did joke. He told that it's very simple. Very simple. Theory of relativity is very simple. That if you call a very handsome boy and a very beautiful girl and ask them, both of them, one by one, that there is an oil, the boiling oil, 90 degrees centigrade, 100 degrees centigrade, 120 degrees centigrade, and ask them to put their hands for 1 second. Oh, they will take their hands out and they will take, what are you doing? You are making us to put our hands in the boiled oil for 1 hour? Now you are telling, you are saying that it was 1 second and 1 hour. They are feeling 1 second as 1 hour. And then you tell them that you talk nicely, loving talk for 1 hour. And after 1 hour, I will come back and I will separate you out. When you go after 1 hour, if they will tell that you are coming within 2 seconds. So this is theory of relativity. So here, you see, the same thing happens. You have to try yourself. Once you try many examples, many iterations, many things like this, you will be able to do the solutions faster. So what I am coming to affect is different, right? Is different. That uh, exercise is not yet complete. If I change the plug setting of R4 and R3 to 10%, that means it was already 10%. I maintain as it is. But plug setting of R1, R2 as 15%. I achieve the faster operating time. And in any protective system, if the relays operate faster, yet maintaining the selectivity, it is always better, my dear friends. So I have only done this PS of R1 and R2 I have changed. And what I have done? TMS of R3, R4, 0.55. TMS of R3, R4, I have adjusted to TMS of R1, R2, 0.5 and TMS of R3, R4, 0.55. This also I have arrived at after many iterations. You see, I don't mean to say that this is at the first point of time I arrived at this. So after many iterations, which I did at my home, myself, using the simple calculator, right? So then time of operation for fault at F1 is 1.153. You can check up. You can check up time of operation of R1 fault F1 in earlier case. Time of operation of R1 for F1. Time of operation of R1 for F1 was 0.23 second. 0.23 second. Here, time of operation of R1 in this case for fault F1 is 1.153. 1.153 and yes, once again, 2.23, right? Sorry, top of R1 is 0.23. And what is the top of R1 for top of R3, R4 is top of R3, R4, plug setting R3, R4, TMS is R1, R2 is 0.5. TMS of R3, R4 is this. Top of R1 for fault at F1 is 1.153. Top of R4 for same fault location is 1.408. Discrimination time margin is maintained 0.255. Top of R4 for fault at F2 is 1.268 and top of R1 is 1.633. Discrimination margin is maintained. it can be appreciated that the relays have operated faster by 0.8 second. Let us see how it is faster, right? I'm rather telling that they have operated faster by 0.8 second. So what is the time of operation of R1? Time of operation of R1 is 1.153, 1.153, right? So what was the time of operation of R1 in earlier case? Time of operation of R1 in earlier case, what with this was 0.3 second, but time of R4 was 0.1873 second, right? But I have selected 0.1, 0.2, so it will be faster. It will be even slower rather than this. And if I take the another case F2, for fault at F2, time of operation of R4 is 0.4611, and time of operation of R4 for fault at F2 for R1 is 0.274. So time of operation of R1 for fault at F1 is 1.95. Sorry, this is wrong. Time of operation of R1, I'm sorry. I repeat, see, time of operation of R1 was 1.9599 there in earlier case. Here, time of operation of R1 is 1.153. Compare 1.153 and 1.9599. 1.153 is faster. R4 you take. R4 if you take, then it was 2.3 second. R4, let me take here. What is R4? If I take R4, the time of operation is 1.408. In earlier case, it was R4 was 2.33, and this is faster 1.408. So you can see that you have achieved faster operating time. What all you have done? There also the exercise was correct. Discrimination 0.25 second was maintained, right? The relays were operating correctly. That is all right. But just by changing the plug setting of R1 and R2 to 15%, I have been able to achieve faster operating time of all relays R1, R2, R3, R4, yet maintaining the selectivity, right? And my friends, this is the only one thing I have tried. I have not tried another plug settings also. Say plug setting of R1, R2 as 20%, because 10 to 40% is available. R3, R4 I change something. Similarly, R1, R2 I change 40%, and R4, R3 I change 35%. I can take many possibilities. You do those exercises at your home and find out which is the most optimum. Most optimum means whatever plug setting you decide, whatever time setting you decide. My requirement is R1 should back up R4, R4 should back up R1, minimum 0.25 seconds should be maintained, R2 should back up R3, R3 should back up R2, minimum 0.25 seconds should be maintained. But yet all four relays should operate as fast as possible. This is optimization of setting. And this optimization of setting is the exercise which is done by PhD students or master students in their dissertation work. But there you cannot take such a simple system. 2 bus, 2 lines, 4 relays, you cannot take. You have to take some IEEE standard system, 5 bus system, 7 bus system, 11 bus system. Exercise is going to be much more difficult. Probably you will not be able to use scientific calculator, and you will have to use the uh, some computer algorithm to arrive at the optimized solution. And yet relays should operate very fast. Discrimination should be maintained, right? And the correct operation of relays have to happen, right? And as I was telling, in a very large interconnected system, for some fault location, maloperations are occurring. Maloperations have not been able to be avoided till date. Till date means 15th 15th December 2021 and 11:50 p.m. Till this time, nobody has proved that overcurrent and earth fault protection can give foolproof protection, my dear friend. And therefore, I repeat that distance protection is the best. Therefore, in all this exercise, what I've done, primary relay backup pairs, same that we have done in overcurrent and earth fault scheme. The whatever I could do till now, that I have summarized, that R1 R2 plug setting I have adjusted at 15%, R3 R4 at 10%, R1 R2 TMS I have adjusted at 0.5, R3 R4 at 0.55. I achieved fastest operation possible. I achieved proper discrimination between main and backup relays, primary and backup relays, and the protective system is correctly operating. You could have observed, you could have appreciated that the exercise is quite complicated, with a very simple primitive network, which is not really existing in practice. In our practice, the networks are quite complicated, and therefore the exercises are also quite complicated, my dear friends. With that, I come to an end of this tutorial 10 on the overcurrent and earth fault relays, that is protection of transmission line using overcurrent and earth fault relays. My dear friend, that is what I am coming to an end. If I go further, the 11th tutorial will be configuration of overcurrent and earth fault relays using 6 different setting groups in numerical relays, and the same exercise I will do for ground relays, right? So that is what we will do in overcurrent relays. Then we would want to take some practicals for engineering institutes, how you can design good experiments. That means all field practices have to be simulated. Radial feeder is to be simulated, parallel feeder is to be simulated, differential protection of generator, differential protection of transformer, right? How to test the relay, different types of relays, CT-PT, that is CT saturation characteristic and CT-PT polarity testing, right? Ground constant of a circuit breaker, that means the overvoltage factor of a circuit breaker. Many experiments are possible. We have designed some 60 experiments in BVM Engineering College, right? So we can talk about many experiments and many engineering institutes. Those viewers who are hearing here in this tutorial, they should be ready to help me out to make those experiments reach to all engineering colleges in Gujarat first, second if possible in India, and third if possible in world. You see, no one have yet designed good power system laboratory, good power system protection laboratory that is designed by me at BVM Engineering College is now worldly known, because IEEE transactions in power delivery, they have published a paper in 2005, so it is internationally accepted. Uh, the paper has been rather, आप क्या बोलते हैं जिसको, it has been quoted by many people after that. After that, many people have quoted that paper, because that paper has become very popular. Because to simulate the system condition, power system condition in laboratory at, at possibly very low cost, that is a difficult and special art. By the grace of God and by the grace of my great Guru Dr. Date, I have been able to learn these things. Dr. Date used to carry out all such experiments, and I extended them further. And these experiments also we will be talking about in overcurrent and earth fault protection when we go to laboratory. And then we will resume to distance protection of transmission line, my dear friends. So as on date, some 23, 24 tutorial presentations are ready with me. This is 10th and 25 will come to you, and then by the end of this year, by the end of the year 2022, maybe somewhere in October, November 2022, you will be getting 150 free of cost tutorials on YouTube, and you will understand the complete subject power system protection. My dear friends, I told that for learning this subject, these tutorial laboratory tutor, YouTube tutorial videos are there. My book is there, which I told I will repeat, Power System Protection and Switchgear by McGraw-Hill Education International. That book is also available. I repeat, Power System Protection and Switchgear by McGraw-Hill Education International is available in hard copy and e-copy. I have published modules, 3 modules, and this fourth on distance will come up. There will be 9 or 10 modules in power system protection being uploaded on Adapt.me, but on payment basis. But there also you will learn power system protection in a nice way. So I am there to share my knowledge and to make you expert in power system protection. If you stick with Adapt.me, एडपमी के साथ जुड़ जाना है. You have to join yourself. You have to connect yourself daily, moment to moment. Edupme, EDUPME. Remember this word. They will teach you everything. Everything. I can teach you then all subjects in electrical engineering. But then Edupme. Edupme, you have to remember, my dear friends. So, with the sweet dreams that you will get about Adapt.me, with the sweet dreams that you will see about power system protection up to tutorial 10.9. I thank you all. Good night. Good night, everybody.